Hello, welcome back to my bench. If I haven't put a video out in quite a while, and that's because I went out and did the visit the family thing, and because I've been working on a bunch of stuff that you've seen me do a lot of. Replacing capacitors gets to be old after a while, and so if it's something you've seen a bunch of times, I don't bother to do the videos anymore because why bother? But today we got something different. This is a Symetrix 581E. It's a 4x4 distribution amplifier. Basically, that means you have one in, you got 4 going out for 4 different channels. These things and its cousins are used all over radio stations, and they work. They all work pretty good. This one's pretty simple. I mean, basically, it's got a power supply and a couple of line drivers for outputs. These outputs on the front, and a bunch of inputs and outputs over here on what are these? These are 85 or 4580 ICs, 4580 or 4560, 5532s and 4560s. 5532s for the inputs, 4560s for the outputs. I figured, since I've worked on these before, I figured that I knew what was wrong with this one when it came in. What happens is all of these lights will light up on the front here. These are your indicators. They go in the bottom one here is the lowest amount, more input, normal, zero level input, and clip. And all the lights light up, and when that happens, that means that you have bad capacitors on the outputs of the voltage regulators. This particular unit has 2 sets of regulators on it. It has one back here, which is the plus 15 and the minus 15. They come right off the output of this transformer here. The rectifiers are in the back. And another set over here. They are exactly the same. These drive this bank, these drive this bank, these 2 inputs and outputs, and then these 2 input and outputs over here. And when these capacitors go bad, these are 10 microfarad at 35 volts. When they go bad, they'll basically just turn into nothing, not capacitors anymore, and the whole thing just goes into silly oscillations, runs away, and all the lights come on in the front. So that's how you can tell. So I already replaced these caps, thinking, well, that'll do it. But now we got another problem, and that problem I'll show you here. We'll hook this up. I don't have any of the Euro plugs for this. Which one is this? This is output. We'll go down here because it gets it out of the way. I'm just going to clip these in with clip leads. That's output. This is input. There we go. And we'll plug it in. Yes, I am turned off. Okay. So, if we bring up the scope, here, we got channel 1 showing up on the scope. Turn off channel 2 at this time. Bring it down here so we can see it. We just got noise. Let's turn it on. Woo, that's a lot. Come on. What are we doing? There we go. Alright, so if you look, you can see that it's got an audio output, but it's bouncing around in there pretty badly. It looks pretty awful. So we got to trace down what's wrong with it. So to do that, we'll take some voltage measurements first, of course. So let's get the meter up here. We'll take our voltage measurements. Here is our plus 15 volts, I think. Yep. There's plus 15. The drive from this thing is where? Somewhere there, 22.5 volts. And the output is plus 15. And this is the negative. Input is over here on the tab. It's minus 18. Minus 18 going in. And coming out, I got minus 12. So I don't have the right input or output. So let's check this set over here. Same thing, minus 12 volts. This one, the output is 14.8, and within reason. Well, I did change the capacitors. This one, the capacitors have been changed. They are not warm. These guys are not warm. They're pretty well glued down there to a heat sink that's on the board itself. Let's check. They've got a couple of diodes. I can't find a schematic on this to save my life. They got a couple of diodes on here. So if we look at, then they go right across the input and output, or input to ground. Yeah. So let's check the diode. 1.2 that way. 0.511. That's okay, I think. Let's check this one over here. If I can get on it. 0.6. Okay. Let's go over on this side. 0.606. This. Wait, come on. That's good. Open, more or less. And go the other way. 0.516. So I'd say those diodes are good. I mean, if we test other diodes here. 0.567. Okay, they're fine. Those are good. So where are we getting? I don't think I've got any shorted capacitors. These little service mount caps you got to be careful about. No, that's good. No, and I didn't short my inputs. Nope. You always got to check when you put these little service mount caps on. Make sure you check. No, not shorted. Not shorted. Going up. Not shorted. Okay. Well, I have an idea. I wonder. Let's take a scope here and get channel 2 up. Let's put channel 2 on. Get rid of 1. I got this probe in DC and times 10 because that's sort of what this does. It's just a capacitor in series. So let's turn it back on. And what I want to look at is I want to look at the inputs to these things. Here is input for the plus 15 volts. That's, what is that? 5 volts. So we're looking at 9 volts peak to peak. Yeah, at 123 hertz. So it's doubling, which is what I would expect. And the output of this guy is pretty clean. Yeah, 200 millivolts. We got almost nothing on the output. Let's check this one. The input is here. Oh, Wow, okay, I'm on 20 volt scale, 120 hertz, and it says 26 volts peak to peak. The output, look at that output. That output's got 15 volts peak to peak on the output. Okay, I think I know what's happening here. Bet you when he changed the capacitors, because somebody's changed the capacitors, I bet you he broke the traces. Because it's really easy to do. These things are built just like the 528Es. So, yeah, it's been replaced. Let the soldering weapon heat up here for a minute. Yeah, for a second. We're about 380 degrees. Yeah, I've seen this before, especially with these voltage regulators. So we're gonna look at it. This thing's been used a bit. See the darkness? That's where it gets hot. So this thing's been in a rack quite a while. Look at this. These are all been nice and warm. That's cool. All right. All loose. Okay. There's my cap. Let's get this guy down. And I'll bet you what we're going to find out is this thing is way out of tolerance. Let us find out here. And no unknown or damaged part. Okay. What? Let's take this guy and test him. That's that may be worse than I think. Plus, turn it on. This is 1,000 microfarad at 35 volts. Negative. Oh, wow. It's nothing. It's a nothing. It's a nothing cap. It's not even registering. Wow. Oh, and it's brand new. What? LH Nova. LH Nova cap. 1,000 at 35. Let's take this other one out. I mean, it was okay. But, yeah, I got to get a new solder sucker. That one's falling apart. This one has a little bit of glue on it. So let's test this one and see what it says. Negative, positive. It says 210, 217 is 1,000 microfarads. Wow, let's try it on a different machine to see what it says. I'll bet you it says close to the same thing. And it's an LH Nova also. Seal. And turn it on. Takes a minute for this thing to measure caps this high. 354.1 microfarads at 4.5 ohms. Alright, both of these caps are crap. Hang on. Have I got 10 at 1,000, So I want 1,000 at 35 or 1,000 at 50. Wow. Well, there is 1,000 at 50. Well, let's see if I got any more. Hang on, I'll be right back. Okay, I don't have any right now. I found some good ones, but these are used. We're just going to try it, and I'll order new ones. I need to get more because I got 528Es to do. These are 1,000 at 50. I think these actually fit the footprint. Maybe. Yeah, they do. All right, there's one. Clean it off a little bit. And you know, maybe, no, they've been changed, I'm sure. Come on. Rats. That's the problem with using used ones. You can't get them in the hole sometimes. Of course, it would help if they were straight. And would also help if the hole was empty. Okay. Ah, went right in there. Perfect. Sit. All right. Yes, I will get new caps for this. If this fixes it, I'm pretty sure it will. All right. Caps in there. Take my input for output to my input. Negative, positive, negative, positive. Volume off. Plug it in. And poof, turn it on. Well, it looks like I've got, let's see what we got now. Yep, there it is. There you go. So, interesting. Turn off channel 2. Nice and clean. Beautiful. Turn it down. Turn it up. Yeah. Beautiful. All right, so take our voltage readings now again and see what we got. Put on volts. Alright, on ground. My output of this positive regulator is 15.0. Output of my negative regulator is negative 15.2. More than that, let's take a look at the input and outputs and see what they look like. Channel 2 and scope. Alright, so here is my input from channel 1. And I am at 20 volts, 50 volts. Alright, so that's reading that noise. Let's turn off the function generator. See what we got now. Alright, let's take a look at the input or the inputs and outputs of our voltage regulators. Here is the input of this voltage regulator, and I'm on 20 millivolts on channel 2, so we're looking at 100 millivolts peak to peak. That was much better than we had before because that cap, remember, was 200 microfarads instead of 1,000. Then my input to channel, the negative side, is about 800 millivolts peak to peak at 120 hertz. Because this cap was no good at all. The output from this one is dead clean. I can't go down any farther. That's 200 millivolts. Alright, and the output of this one, dead clean. Alright, so if you see these voltage regulators, 78 and 7905s, or 7912s, whatever, it doesn't matter, 12s, 5s, 15s. The input is really garbagey. The output is not going to be the right voltage most of the time. You just won't get it. It'll be awful. And you can recognize that if you look at the inputs and the outputs as far as ripple goes. The ripple on the output. These things are extraordinarily good at getting rid of all kinds of noise, just basic noise. Like you saw here, you had 800 millivolts, about almost a volt input, but the output was nothing. It was dead clean. These things are really good at getting rid of a little bit of ripple on the input. On the output from something that's coming in. So there you go. That's how you can tell if you've got bad filter caps. Interesting. So I got to order a couple of 1050s and put them in here in that footprint, because these LH whatevers are bad. I know that these were replaced because the factory would not do that. The factory would not do that. They'd get one with the right lead spacing. Alright, well there you go, guys. I hope you enjoyed that. A little bit of a lesson so you don't chase yourself around in circles. We tracked it down pretty quick. Mostly because I've seen it before, but I'm here to lend some of my experience for you. Thanks for stopping by, and I hope you enjoyed it. If you did, give it a thumbs up. And don't forget to subscribe. And don't forget, if you want to support me more directly, I have a Patreon page. AERV blog over on Patreon. So, thanks for stopping by, and till next time.